Hi viewers, today we are going to dive into a different session, a session for mathematics. So we are doing a revision for a certain paper for test 1 from 2023-2024 academic year. And our first question had a question involving the intervals of subsets, or rather the subsets in short. So let's try to dive into this question, as the question is already being read here. Then you need to understand to say what is it that these people want, especially when they say let R, which is a set of real numbers, be a universal set. If they say that is a universal set, automatically what they mean is your number line needs to run from negative infinity all the way up to positive infinity. So for me to come up with this, I will start by writing the set A on a number line. Then the elements that are not part of set A, I will explain to you how to come up with those same elements. So let's try to dive into this. Start by drawing a number line. A number line has to run from negative infinity all the way up to positive infinity. That's the meaning of a set of real numbers. Okay, so I'll put my 0 here. I'll put my, in short, I have to indicate the numbers that are involved in this set A. So we're starting from -7 somewhere there. We also have an 8 here, and also we have an 11 somewhere there. So remember, when you have a closed interval like this one, this bracket, you need to put a circle on top of that number and shade its circle. Same applies even here. I'll put a circle on that same number and I'm going to shade that same circle. What I mean is the top of this number, which is carrying a closed bracket or a closed interval, -7, needs to have a closed circle somewhere here, of which that circle has to be shaded. I'm going to shade it red. Then when you jump, remember that A is made up of two different sets that are combined using universal, this part as well as that other part. So all what we need to do is we are running from -7 all the way up to +8. So since +8 is carrying an open interval, this type of a bracket, we expect it not to have a circle that will be shaded. Then I'm going to connect this and that one. Finally, I need to shade all the numbers in the middle to indicate that they belong to set A. So this part is for set A. We'll do likewise to the remaining part. Remember, 11 is also having a closed interval, meaning that its circle here has to be shaded. So I'm going to shade this given circle somewhere there. Where is this same set now pointing? So it is moving from 11 to positive infinity. So I'll just make an arrow which is going to point to the right hand side towards the positive infinity, and I'll shade this given part which is for set A as well. Okay. Right, if we try to proceed, we'll notice that since set A is starting from here to the right hand side, here it is starting from -7 all the way up to +8. We expect numbers from -7 to the left hand side not to be part of set A. I think you understand what it means by complement, meaning that all the numbers from here going to negative infinity part, they won't be part of set A. They're supposed to be part of set A complement. Same applies when you jump starting from from 8 all the way up to 11. All the elements in the middle here, they also do belong to set A complement. But the issue is, how do you consider these same circles when it comes to shading them? If for a certain number, initially it had a shaded circle for that specific set, meaning that for a complement, you can't shade that circle. Reason being, here it is already shaded, which symbolize that that element belongs to that specific set. Same applies if initially that number wasn't shaded. On the part of complement, that circle needs to be shaded. When you shade a circle, the type of a bracket you are going to use has to be a closed interval. If this initial was shaded, we expect that one not to be shaded. So this won't be shaded, and also that one won't be shaded. So how is set A moving? It is starting from negative infinity all the way up to -7. Remember, where infinity is concerned, you are not supposed to put a closed interval or a closed bracket, in short. So set A complement is equal to, we are moving from negative infinity all the way up to 7, so have negative infinity here, comma, -7. So since this circle is not shaded, we expect to put an open interval. Then I said where infinity and infinity are, we are supposed to put an open interval, not a closed interval. All right. Then we are jumping from 8, we are going all the way up to that other side, which is on 11. And for A complement, this 8 here, its circle is shaded. We expect it to have a closed interval, I'll say 8. Remember, when writing these things, we are starting from left hand side to the right hand side. Don't make that mistake of writing from right to the left. So say comma, then we have 11 here, I'll say 11. Right, so since 11 on the part of A complement, it is not shaded, it needs to have an open interval. So how do you combine the same two sets? It's when you use the so-called union. So I'm going to use a union to combine these two sets. So this is what we need to get whenever I want to come up with set A complement. Of course, it is also made up of two sets. How do you get set A intersection B? This is a different question which requires us to take note and know how to understand it. So I'll do likewise. I need to come up with a number line which is running from negative infinity to positive infinity. The reason why we are running from negative infinity to positive infinity, because they said a universal set has to be a set of real numbers. So let's try to know how to plot both set A as well as set B. Then we see where these sets are intersecting. So I'll put my 0 here, I'll put my -7 there, I'll put my 8 here, I'll put my 11 there, then I'll put my 20 somewhere there. All right. So if you notice, you understand that we have to sketch set A, we need to also sketch set B. Let me try to start with set A itself. So remember, for set A, we said we have this part, that part, here, going to the right hand side. So this part has to be shaded. Also, that part was shaded. All the numbers in the middle, they are part of set A. Even here, all the numbers somewhere there, they are part of set A. So this is set A, and that is set A as well. Let's try to know how to come up with set B. So set B is starting from here all the way up to 10 somewhere there. And what type of brackets do we have? We have closed interval. So we expect these circles to be shaded circles that are on top of these same elements. So we connect as well. That, remember, set A is here. I mean, set B is starting from here all the way up somewhere there. So shade all these parts, they represent set B. Now, for you to come up with intersection, you need to pick the elements that are found on both set A as well as set B. When you're running from here up to 8, you notice that these elements from here all the way up to 8, they belong to both set A as well as set B. So this part is giving us A intersection B. Again, when you jump elements from this given part to 20, somewhere there, since A is starting from here to positive infinity, meaning that also all the elements here, they do belong to set A intersection B. So how do you combine? For you to combine this part and that part, or what you need to do is you just have to make sure that you try to to combine using a universal set. So A intersection B, A intersection B has to be equal to, we're starting from 0, comma 8, then this side we're starting from 11, comma 20. So what type of brackets do we have? The type of brackets that we are going to have here, a 0 on top is shaded. We expect to have a closed interval. Then 8 here from part A is not shaded. We expect it to have something like this. 11 there is shaded. We expect it to have a closed interval. Even 20 is also shaded. We expect it to have something like that. So be careful on this very part. Whenever you want to combine two sets, that's where and people are missing the concept. For you to combine this and that, use the union middle. All right, let's try to proceed. So the way we are going to proceed, we need to go to this. For you to come up with this given set, or what you can do is you just have to make sure that you start by plotting A union B. How many elements belong to set A and B at large? Then that's when you can easily isolate the ones that are not part of set A and B. So the meaning of union, it has to be a combination of all the sets. So -7, then 8 here, 11, we have 20. So you notice that for set A, we are moving from here, somewhere there, from here to positive infinity. This part has to be shaded, even here, shade, the shade, then the middle part, these elements, they do belong to set A. Set B, we are moving from this given point to that given point. Both are supposed to be shaded. So all these elements belong to set B. So you notice that from -7 all the way up to positive infinity, these elements, they do belong to both set A as well as B. But elements is starting from here, going to the left-hand side to negative infinity. These, they don't belong to set A union B. So here we have positive infinity. So, meaning that from this given point, all these elements here, they are part of set A union B. But from this given part to the left-hand side, they don't belong to set A union B. So what are we going to do? If A union B is equal to from -7 to positive infinity, what do we expect? This guy is shaded here. We're supposed to put a closed interval. Then where we have that, we just use something like that. So all what you need to expect is from here to the left-hand side, we are going to get something like A union B. Union B complement. This has to be equal to. So we are moving from negative infinity to that. Remember, when you're writing the complement, I said if a certain number had a shaded part initially, meaning that for its complement, it won't be shaded and it must have an open interval on that same part. So we are moving from negative infinity to -7. So since we are going to have this type of a circle now, expect it to have that. Then infinities, they must have that type of bracket. This is how you answer the first question, and whatever question you're going to be given, it has to be answered in this way. It's not always that you're going to be given R as a universal set. Whenever you've been given numbers as part of a universal set, meaning that your number line needs to be ending with the same two numbers that you're going to be given as a universal set. Let's try to go to the next question. We see also how to answer that same question from the following test. One more question, which has also been given here. Now, this question is coming from application of quadratic equations, whereby you'll be given either an equation already, or you'll be given a statement like this one. If they give you an equation already, I'll tell you where to start from for you to come up with the answers. But for this one, you need to understand it by coming up with a diagram, then you try to interpret it. They're saying this is a rectangular shape. Of course, a rectangle has to be like this. Right. This same rectangular shape, I'll put 2 dimensions. Let me take the length itself to be x, meaning that that will also be x. Then this part, I'll take it as y, even here as y. So since they're saying 240 meters is the one which is enclosing this part, we expect to write it as 240 meters in numbers. So if they say enclosed, they mean the total perimeter of that same shape. And how do you get the perimeter? So we say perimeter has to be equal to the total sum of the length around the shape. So you add x and x to get x. You add this and that to get to y. So the total, friends, they're saying it has to be 240, meaning that on the part of perimeter, I'll put 240. So we have 2x plus 2y. This has to be 240. You can reduce this. So it will be x plus y. This has to be equal to 120. I'll take this to be the first equation from perimeter part. They're talking about the issue of area in this case. How do you get area? If you see something like to maximize the area, or what they want you to do is you need to make sure that you know how to get the area of that specific shape. It could be a circle, it could be a square, it could be a rectangle, it could be a trapezium. Or what you need to do is to know how to get the area of that same given shape. So the area of this given shape, A, is given by length multiplied by the breadth. The length has to be an x, then the breadth I'll take as a y. So area has to be equal to x multiplied by y. I'll take this one as equation 2. So from equation 1, we can try to make y the subject. Then whatever we get, we'll come and replace it here. So say make y the subject from 1. So how do you make y the subject from the same first equation? Wow, something which is very simple. Just say y is equal to 120 minus x. Then substitute this into that, and your area is going to be equal to x 120 minus x. So in this case, our area has to be equal to 120 x minus x squared. This is something which is in a form of a quadratic equation. Not really in a form, but this has to be a quadratic equation. And it has to be written like this. It has to be negative x squared plus 120x. Remember, the constant is 0. For you to easily get the value of x under this topic, it could be a variable of x, it could be a variable of t, whatever you are going to be given. What you are supposed to do here has to be, you need to use a certain formula which is going to be applied based on the variable you've been given. So some questions you find that they're going to be given already from here, whereby this will be an equation for money and the like. So what are we supposed to do? For you to get the variable of x, in short, this variable which is here can be replaced by whatever variable you can be given in the question. It could be t for time, it could be k for quarter, or whichever. So for me to get the value of this same variable x, I'll say x must always be equal to negative b over 2a. So whatever you can be given, if your equation has already been given in a form of this, they're saying how much time, how much money, or what you need to do is use the same by taking this variable to be equivalent to what you've been given in the question. Okay, so in short, x is equal to, what is a b? A b has to be this coefficient of x, I'll say negative 120 here, over, what is our a? Our a has to be negative 1, and this simply means we are getting something like 16, I'll say meters. So from here you can also get the value of y, whereby y is equal to 120 minus x. So y is equal to 120 minus 60. This is also giving us 60 meters. So don't worry about those dimensions to be same. This is exactly what you're supposed to do. And for you to maximize the area, you just have to say our area has to be the one which is here, say 60 multiplied by 60. This is going to be 3600 meter squared. That's how you deal with such type of questions. If they give you an equation already, all what you have to do is just to make sure that you go direct from this point to that given point, depending on the variable you have. You're supposed to put it here, then you'll be able to get the value that you're supposed to get for that specific question. Let's try to proceed to the next question, which is question C. We need to understand how to answer that same question as well until we go to question D. All right, we proceed. One more question, which is from C. It deals with arithmetic and geometric progression. So this is for geometric progression. Under geometric progression, you need to know two things. The first one, the first thing that you need to understand from geometric progression is what formula can you use to find the nth term. From there, again, you need to understand how to get the so-called common ratio. So the formula that we normally use for us to find the nth term has to be a r at power of n minus 1. And then for common ratio which is denoted by r, has to be equal to the division of the second term by the first term. Then for you to come up with the third term, of course, third term will be coming from this very part. So from this sequence, this is our first term, which is a, that is our second term. So in simple terms, I'll call this T1, I'll call this as T2. So where we have a, it represents the first term. Okay, so how do you get the same common ratio? Common ratio r has to be equal to, the second term is 3 minus 2 root of 2, and our first term is square root of 2 minus 1. So you're not supposed to leave your answer in said form or leaving your denominator to be in a form of a complex number. That is not allowed. So we are going to multiply both the numerator and denominator by the conjugate of a denominator to get rid of this same guy which is here. So the conjugate for this, you notice that it has to be having a different sign between this number and that, or between a set and that number. So the conjugate for this, in short, has to be square root of 2 plus 1. It doesn't matter whether you put this here, you put that there, still more the answer will just come out the same. So I'll say over square root of 2 plus 1. So r as a common ratio is equal to, you have to multiply what is here by everything on top, but here you are going to multiply this by that, then this by that, straightforward to avoid repeating things that will cancel already. So 3 multiplied by that, this is 3 square root of 2. 3 multiplied by that, that is 3. Negative 2 square root of that multiplied by this, it will be negative 2. Of course, the square root of 2 and the square root of 2 will just give us a 2 when we multiply them. And then square root of negative 2 square root of 2 multiplied by that, it will be 2 square root of 2 over. I said when you're multiplying the original number by its conjugate, you multiply the corresponding this, multiplied by that, it will be 2, and this and that, it will be minus 1. So r is equal to, if you check, it's more like you're saying 3x, then here we have negative 2 x. So meaning that this and that will subtract one another since they are having the same sets. So this minus that, it will just give you square root of 2. Then here when you check, we have 3 minus a 4, which is going to give us minus 1. Denominator 2 minus 1, that's 1. This is our common ratio. When we come on this part whereby we want to get the third term, it simply means n has to be 3. So third term has to be equal to, what is our first term? Our first term is square root of 2 minus 1. Then what is our error? Our error is square root of 2 minus 1. And here we have a 3. So it will be 3 minus 1, that will be 2. If you check these things, this and there, they're just the same. If you say this is x and also that is x, then it's more like we are multiplying x multiplied by x squared, which is going to be x power 3. Same applies even here. Our third term will just be the same as square root of 2 minus 1 to the power of 3. This is the third term these people wanted. Let's try to go to now the other question. Now the other question, it has to be question D, of course. We need to go to question D. Question D is somehow involving. It requires you to combine some concepts for you to solve this same problem. First of all, you need to know how to deal with this for you to factorize it. When you happen to factorize it, of course, that will be the factors you are going to use for you to come up with the range of values. So it's more like if you take this to the left hand side, then your expression will just be the same as 2x plus 8 greater than 0. How do you factorize a polynomial function? Here we are going to use a trial and error method, whereby I'll be picking numbers that if you try to put it on the part of x, it must give you a value of 0. So we'll start with positive minus 1, then positive minus 2, positive minus 3. You can keep on moving. This is the best way to deal with polynomial functions in case they say factorize. So when we try to get positive 1, which means your linear factor was x minus 1. If you get negative 1, meaning that your linear factor was x plus 1. Because if you try to equate these numbers to 0 and find the value of x, it will give you something which is going to be a negative. For this one, there it will give you a positive. So when we try to have positive 1, you try to put it here. What are you going to get in this same case? So it will be 1 to the power 3 minus 5, 1 squared plus 2, 1 here plus 8. So it will be 1 minus 5 plus 2. Start. Of course, this one, I think it can't give us a 0. Okay, let's try to test for negative 1 for us to come up with a linear factor as that one. So negative 1, you plug it here, it will be negative 1 to the power 3 minus 5 negative 1 squared plus 2 negative 1 plus an 8 somewhere there. So this would be negative 1, then this will be 1 multiplied by that, negative 5. Here it will be negative 2. So this part, I think it will give us a negative 8 plus 8 plus 0, meaning that our factor is x plus 1. So me, I love using a long division method for us to simplify this. How do you use the same long division method? If you pick this to be a factor, of course, this has to be under the root. So say x power 3 minus 5x squared plus 2x plus 8. So you always divide x into the highest power of x on this given part. Meaning that if you say x into x squared, I mean x power 3, that will be x squared. When you do that, you notice that we are going to multiply this by that to give us x power 3. Then this and that, it will be plus x squared. And then you're supposed to subtract. So you subtract this and that, this and that. So x power 3 minus x power 3, that is giving us something like a 0. We ignore it. Negative 5x squared minus this one, we are going to get something like negative 6x squared. Even here, you divide this into that until you find that the value of x, which is here, is greater, or the power of x here is greater than the power of x on what you're supposed to divide into. So when you take this into that, what are you going to get? Of course, you'll get something like 6x. So this is negative, and our answer has to be negative 6x. So this multiplied by that to be negative 6x squared. This and that to be negative 6x. So we have to drop this comma plus 2x, and also we'll subtract this part. Negative 6x squared minus negative 6x squared. These two will go. Then we have 2x minus negative 6x, that would be 8x. We divide again x into that will give us positive 8. So 8 multiplied by that, 8x, this and that, plus 8. Drop this guy again. When you subtract here, you get a remainder as 0. So remember, we're supposed to get exactly the same as what we got previously when we were testing to say our factor has to be that. So mainly, if these numbers fails, you go to the second numbers until you find that there will be a certain number that is going to be giving you a 0. So our first factor is here. I'll write it here, x plus 1. Our second factor is this one, x squared minus 6x plus 8. Using simple factorization, I believe this can be reduced. How can you reduce this one? If you try to use simple factorization, how can you reduce that one? So it will be x squared minus 2x minus 4x plus 8. So it will be x. So x minus 4 and x minus 2. So if we try to attach even this part, we're going to have 3 linear factors. So this is exactly the same as x plus 1, then x minus 2, x minus 4, greater than 0. What do you remember about this? You have to start by getting the so-called critical values in case you want to get the value, the range of x. So we are going to have x plus 1 equal to 0, x minus 2 equal to 0, and x minus 4 equal to 0 in order to get the range of values. So this gives us negative 1, that gives us 2, this gives us 4 as the critical values. And we'll go direct into drawing a sign table. Our sign table will have numbers starting from the lowest, negative 1, 2, 4 there. Then we have x plus 1 here, have x minus 2 there, and x minus 4 here. Then we have our final sign. All right. So what are we going to do next? Or what we need to do now is we are going to be testing numbers from this part, there, and there in these numbers for us to get the signs. So what number can we test here for this given column? Let me try to test negative 2. Between this and that, I'll test a 0. Between this and that one, I'll test a 3. From there, I'll test a 5. How do you test? When you get this number, you plug it here. You always write a sign of that final answer you're going to get. So for instance, if we say negative 2 here, it will be negative 2 plus 1. This is going to be negative 1. Just write a sign of that same number on this part, negative. So when you put a negative here, it will be negative 4. I'll write negative. When you put negative there, it will be negative 6. I'll write negative. Then when you put a 0 here, it will be positive 1. I'll just write positive. 0 there, it will be negative. It was negative 2. Here, negative. And there, positive. Here, it will be positive. There, it will be negative 1, negative. So here, we're going to get positive, positive, positive. For us to get the final sign, we multiply all these signs and I'll write the final sign. So negative multiplied by negative, that's positive. Positive multiplied by negative, it will be negative. Positive, negative, negative, negative multiplied by negative, that's positive. Here, positive multiplied by that negative. There, plus. So since we are using a greater than, we expect our answer to lie on the positive as the final sign. So here our positive is within this number and that number in between. Then here it is starting from this number going to the right hand side where we don't know exactly. So since we have this type of a symbol, we expect not to shade these circles. If these circles are not shaded, we expect the type of brackets to be open intervals only. So here we are going to have -1, 2, then there we are going to have 4 all the way up to positive infinity. So due to the presence of this type of a symbol, that's why we are pointing where we have positive numbers, even here where we have a positive number. And then that symbol tells us that we are not supposed to shade these two circles. So if you are not shading the circles, the brackets are supposed to be open, intervals here and there. So solution set for the range has to be equal to, you combine this set and that set using a union in the middle. If it was to be like, let's say maybe they were using less than here, your final answer must lie on the part where we have a negative as the final sign. So we are supposed to move from here to the left hand side, then here to that given part in the middle. So for less than, our answer was supposed to move from negative infinity all the way up to -1. Then we jump, we start from 2 all the way up to 4. So be careful with this part because it is very, very important for you to understand how to deal with this. I'll say I'll end here on this very question. Try to subscribe to our channel, try to share with your friends, like, and also leave a comment. Bye bye.